Okay, so this is differentiation where instead of y equals, you've got x equals. So the 2016 paper, question 5 on this one, we have got this here, and we've got to find the x coordinate of the turning point. So the turning point is where the gradient is 0. Therefore, we've got to differentiate and set it equal to 0. Now, some of the other videos, we've already had a look at differentiation. So here, this is differentiation where we've got to use the product rule because we've got this function multiplied by this function. So in that case, we're going to let u equal e to the power of 3x, and we're going to let v equal cos 4x. Now with the product rule, you've got to do du by dv. So du is going to be e to the 3x, but then we differentiate this 3x, and then whatever that is, we stick on the beginning. That's going to be 3e to the 3x. And dv, when we differentiate cos, we're going to get minus sine 4x, but then just like in the last video, we have to differentiate this thing here, what we're causing. So if we differentiate 4x, we're going to get 4, so it's going to be minus 4 sine 4x. And then when you differentiate, you're going to have u dv plus v du. So u dv is going to be minus 4e to the 3x sine 4x. That's this thing times by this thing here. And then plus v du, which is going to be 3e to 3x cos 4x. Now if we're going to find the turning point, we're going to set that equal to 0. And then what we can do is we can factorize out e to the 3x. So if we do that, e to the 3x, we take this bit first of all, that's going to be 3 cos 4x. Then you need to multiply it by minus 4 sine 4x equals 0. Now if you're going to have two things multiplying together to make 0, e to the 3x can never be 0, because remember e to the 3x is just a graph that looks like that, and it never actually equals 0 because the x-axis is an asymptote. So that means we've got to make this thing here equal 0. So we're going to have 3 cos 4x minus 4 sine 4x equals 0. So if we bring this to the other side, we're going to have 4 sine 4x equals 3 cos 4x. And then we're going to bring the cos over to the left-hand side. We're going to bring the 4 over to the right-hand side. So we've got sine 4x over cos 4x equals 3 over 4. That's going to be tan 4x equals 3/4. And if we have a look here, we've got it in terms of radians, so make sure you calculate it in terms of radians. I'll do the same. Okay, done. Now if we're going to have tan of something equals 3/4, it's not tan of something, it's tan of 4 lots of something. So we've got to turn into tan of A equals 3/4. But therefore then the A is we're going to need to multiply it by 4. So A is going to need to be between, we multiply this thing by 4. Sorry, a little clearer. We multiply this thing by 4. I'm going to get A is less than 2 pi. Times this thing by 4. That's going to be between pi. So tan of A, so if we draw the tan graph, pi over 2, that's pi, and that's 3 pi over 2, and that's 2 pi. And what we're going to do is we've got to find out when A equals 3/4. So 0.75 or 3/4 is there, so that's that solution and that solution. But only one of these is between pi and 2 pi, and that's this one here. So if we do inverse tan of 3/4, and then we add, so that's going to give us 0.64, which is this solution. So this solution, you need to add pi onto it, and we get 3.7851. And that's our answer. Notice that we've only got one answer there, but if you have a look here, it says give your answer, not plural, just singular. So give your answer to 4 decimal places, so pretty sure we've not made any mistakes there. Okay, next question. Given x equals this, we've got to find dy by dx. So usually, certainly on the past 3 papers, as you'll be able to see from this video, you're given something in terms of x, and you've got to differentiate it in terms of y. So we've got x equals sine 2y squared. Notice that it's written as sine squared 2y, but we're going to write that as sine 2y squared. It's exactly the same thing. The first thing we do is we do dx by dy. And what we've got here is the chain rule. So we bring the 2 down to the front, so that's going to be 2 lots of sine 2y. Then we've got to multiply it by whatever's inside the brackets, differentiated. If we differentiate sine 2y, we get cos 2y. Then we have to differentiate what's inside the brackets there, and multiply it, so that's going to be times 2 cos 2y. So that gives us 4 sine 2y cos 2y. Ooh. Now, as soon as you see sine something, cos something, we should know the expansion of sine 2a equals 2 sine a cos a. It's something that we've got to know, just like the expansion of cos 2a is cos squared a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a. These are all the expansions of cos 2a. If you know that sine 2a is this thing here, we can actually say dx by dy here equals 2, let's try that again, equals 2 times 2 sine 2y cos 2y, which looks remarkably like this. So we can say, if this is sine a cos a, that's going to be sine 2a, so that's going to be times sine 4y. So it's going to be 2 times sine 4y. So this is what dx by dy is. So dy by dx equals 1 over 2 sine 4y. And we've got to make it look like this here. So because 1 over sine is going to be cosec, the natural thing is to say that's going to be 2 cosec 4y. However, take a second, because that's the same as a half times by 1 over sine 4y. Just going to repeat that one more time. So 1 over 2 sine 4y is the same as a half times sine 4y, because you just times the bottom, so the 2 remains on the bottom. So this sine 4y is the same as cosec 4y. So that equals a half cosec 4y. And now we can see that P is a half and Q is 4. So that's how you do that one. Just be careful on that. It's not the easiest questions. But again, as long as you've seen this video and you've seen that the past 3 years, this is how to do the question, it's not too bad. So let's have a look at the 2015 question on that. So we've got this thing here. So again, we've got x equals. But this one looks a little bit more complicated. So what I'd be tempted to do here is I'd be tempted to expand the brackets. Get x equals. So if you've got a bracket squared, you can write the bracket out twice. So 4y minus sine 2y. So that's going to be 16y squared minus 4y sin 2y. So that's going to be minus 8y sin 2y plus sine 2y squared. Now, given that P has, that's perhaps didn't even need to do that. Perhaps I just jumped the gun, but usually that's the sort of question it asks. Let's have a look at this. So, given that given that P has x, y coordinates P and pi over 2, where P is a constant, find the exact value of P. So, we're told the y coordinate, there you go. The y coordinate is pi over 2, it's in the x coordinate. So we know that the x coordinate equals 4 lots of pi over 2 minus sine 2 lots of that is going to be sine pi. Also, minus sine of pi squared. Now sine of pi, sine of 180 is 0. So it's going to be 4 pi over 2. It's going to be 2 pi. So times that by itself, 2 pi times by 2 pi is going to be x equals 4 pi squared. And that's the exact value of p. Okay, so yeah, 4 pi squared. The tangent to the curve at P cuts the y-axis at A. So the tangent, therefore we need to work out what the tangent is. So we need to know what the gradient is. So if we've got dx by dy, so if we've got x here, we can do dx by dy. So if we differentiate that, we can either differentiate this. If we differentiated this using the sine rule, that's going to be 2 lots of 4y minus sine 2y. Power of 1 times whatever's inside differentiated. So if we differentiate inside, we get 4, and we've got to differentiate minus sine 2y, so that's going to be minus 2 cos 2y. That's dx by dy. So then what we can do is we can substitute our y value in there, and that's going to give us the value of dx by dy. So dx by dy is going to be 2 lots of 4 times pi over 2 minus sine of pi times by 4 minus 2 cos of pi. That's going to be 2 times by 4 pi over 2 is going to be 2 pi. Take away 0. It's going to be times 2 pi. Times by cos of pi, cos of 180 is minus 1. So it's going to be 4 minus 2. It's going to be times by 6, which equals, unless I'm mistaken, 24 pi. Let's go check. Of course it's right, didn't need to check it really. So now we've got dx by dy as 24 pi. So then dy by dx, we're going to get 1 mark for doing this. We're going to flip upside down, so it's going to be 1 over 24 pi. And if we're going to work out the tangent, y minus y1, that's going to be y minus pi over 2 equals a gradient which is 1 over 24 pi, x minus x1. Now our value of x was 4 pi squared. Now if we're looking at where it cuts the y-axis, we've got to find the coordinates of A. So this here we can treat as our unsimplified equation of the tangent. It doesn't need to be simplified because it doesn't ask for it in its simplest form. We need to find out where it crosses the y-axis. That's when x is 0. So we can have y minus pi over 2. If we set x equal to 0, we can then do this times by this. That's going to be minus 4 pi squared over 24 pi. So let's cancel out one of the pi's. 4 over 24 is going to, so you're going to have y equals minus 4 over 24 is minus 1/6 of pi, so pi over 6 plus pi over 2. So if we make those both pi over 6, it's going to be 3 pi over 6. Minus pi over 6 plus pi over 6 equals 2 pi over 6, which actually equals pi over 3. Obviously that's the y-coordinate. So the x-coordinate we know is 0, and the y-coordinate is going to be pi over 3. So now, the 2014 version of this question. Question 3, so hopefully it should be a little bit easier than the last couple of questions. So to verify that P lies on C, what we've got here is we've got a curve which is x is 8y tan 2y. So what we're going to do is we're going to substitute in our value of y, and hopefully that should give us x. So x equals 8 lots of pi over 8 times by tan of 2 times pi over 8. That equals pi times by tan of pi over 4. So tan of pi over 4 is going to be 1, so 1, which equals pi, and x equals pi, so therefore, yes, lies on the line, or on the curve even. Sorry, curve. Find the equation of the tangent at P in that form there, where the constants a and b are to be found in terms of pi. So if we've got to find the equation of the tangent at P, we've got a coordinate already, now we need to know what the gradient is. So the way we work out the gradient is going to be dx by dy. So dx by dy equals, now we've got something times by something, so we've got two functions multiplied together. So u equals 8y, and we've got v, which is tan 2y. So du equals 8, and dv, if we differentiate tan 2y, if you look at the formula booklet, if we differentiate tan of 2 something, you're going to get something sec squared of that something. Let's make that make a little bit more sense. Tan 2y is going to be 2 sec squared 2y. So u dv plus v du, just as we've done before, is going to be 16y sec squared 2y plus v du plus 8 tan 2y. That's dx by dy. So now if we substitute our value of y into that, so in fact, because we've got sec squared, we can turn that into 16 over cos 2y squared. That's 8 times tan 2y. And then dx by dy. If we substitute y into, so x over 8 into this, we get dx by dy equaling, you get 8 plus 4 pi plus 8. So that's dx by dy, so therefore dy by dx equals 1 over 8 plus 4 pi. And then we've got to put it into this format here. So we're going to have y minus our y coordinate, so y minus pi over 8 equals our gradient, which is 1 over 8 plus 4 pi, x minus our x coordinate. So then let's multiply this out. So we've got y minus pi over 8 equals x over 8 plus 4 pi minus pi over 8 plus 4 pi, and then you're going to add on the pi over 8. Y equals x over 8 plus 4 pi minus pi over 8 plus 4 pi plus pi over 8. And then if we, so then we've got to have ay. But a and b are to be found in terms of pi. So if we times everything by 8 plus 4 pi, 8 plus 4 pi y equals x minus pi plus pi 8 plus 4 pi over 8. 8 plus 4 pi y x. Oh, rid of that. Minus pi plus 8 pi plus pi squared over 8. So that's going to cancel with that. Leave this up there. Minus pi plus pi cancels out. So we've got 8 plus 4 pi y equals x plus pi squared over 8. And that's it. And that's how you do those questions. Good luck with your exam tomorrow.